Welcome to What Is, the show where we take the universe's most complicated questions and try to answer them before your coffee gets cold. Today, we're tackling the Holy Grail, the white whale, and the ultimate unfinished homework assignment of science, as we ask, what is the theory of everything, and why don't we have one? Imagine you're building a Lego set. You've got the instructions, the pieces are clicking together, and it looks like a majestic castle. But then, you realize the bottom half of the castle follows the rules of Lego, while the top half only stays together if you believe in it and bark like a dog. That is essentially the current state of modern physics. Right now, humanity has two different sets of rulebooks for the universe. Rulebook number 1 is general relativity. This is Albert Einstein's masterpiece. It deals with the big stuff, stars, galaxies, and gravity. It tells us that space and time are linked in a four-dimensional fabric, and gravity happens because heavy objects warp that fabric. Think of a bowling ball on a trampoline. It's smooth, it's predictable, it's elegant. It's the adult in the room of physics. But then, we have rulebook number 2, quantum mechanics. This deals with the small stuff, atoms and subatomic particles. And let me tell you, the subatomic world is a nightmare. In the quantum realm, particles can be in two places at once. They can teleport through walls, and they don't even decide where they are until you look at them. If general relativity is a professional ballroom dance, quantum mechanics is a mosh pit at a heavy metal concert where the floor is made of lava. Here's the problem. Both of these theories are incredibly successful. General relativity gave us GPS and explained black holes. Quantum mechanics gave us lasers, transistors, and the smartphone you're probably using to ignore your responsibilities right now. They both work perfectly in their own neighborhoods. But the moment you try to use them together, the math literally catches fire. It produces infinities. And in physics, an infinity is basically the universe's way of saying, error 404. Logic not found. This is why we need a theory of everything. We want one single, master equation, a God equation, that explains how the universe works, from the smallest vibrating string to the largest cluster of galaxies. We want to unify the four fundamental forces of nature. Let's meet the contestants. First, you have electromagnetism, the stuff that keeps your fridge magnets on and your heart beating. Then, the strong nuclear force, the superglue, that holds atoms together. Third, the weak nuclear force, which is responsible for radioactive decay. Physicists have actually done a pretty good job of inviting those three to the same party. We call that the standard model. But the fourth force, gravity. Gravity is the guy who wasn't invited, showed up anyway, and refuses to use a coaster. Gravity is much, much weaker than the other three, and it refuses to play by quantum rules. So, why don't we have this theory yet? What's the holdup? Well, the leading candidate for decades has been string theory. String theory suggests that if you zoomed in far enough on an electron, like way past the wait, stop zooming point, you wouldn't see a dot. You'd see a tiny, vibrating loop of string. Depending on how that string vibrates, it becomes a photon, or a quark, or a graviton. It sounds beautiful. It's poetic. It also requires the universe to have 11 dimensions. Yeah, 11. We only experience 4, length, width, height, and time. String theorists argue the other 7 are curled up so small we can't see them. It's like looking at a power line from a mile away. It looks like a one-dimensional line. But to an ant crawling on it, there's a whole extra circular dimension to explore. The catch, we have 0 experimental evidence for string theory. To see these strings, we'd need a particle accelerator the size of the Milky Way galaxy. Our current budget covers slightly less than that. Then there's loop quantum gravity. These folks argue that space itself isn't a smooth fabric, but is made of tiny, discrete loops woven together. It's like digital fabric. Zoom in enough, and you see the pixels of reality. It's a great theory, but it also hasn't been proven. So, we're stuck. We're like detectives at a crime scene, where the fingerprints belong to a ghost and the DNA belongs to a dinosaur. Why does this matter to you? Aside from being the ultimate fun fact at a dinner party, a theory of everything would be the final key to the cosmos. It would tell us what happened at the exact millisecond of the Big Bang. It would tell us what's at the center of a black hole, where gravity is so strong and the scale is so small that both our current theories just start screaming and jump out the window. It might even tell us if time travel is possible or if there are parallel universes, where you actually remembered to take the trash out this morning. We don't have a theory of everything yet, because the universe is a stubborn mystery. It doesn't give up its secrets easily. But that's the beauty of science. We are a bunch of hairless apes on a wet rock, trying to calculate the weight of the stars and the vibration of the invisible. We haven't solved the puzzle yet, but we're getting really good at finding the edge pieces. Maybe the theory of everything is just around the corner, waiting for a new Einstein or a new Curie to look at the math and say, "Oh, duh. It's so simple." Until then, we'll keep smashing particles together and staring at the sky. Thanks for watching What Is. If this video made your brain hurt in a good way, hit that like button and subscribe to join us for more deep dives into the how and why of literally everything. Drop a comment below. Do you think we'll find the theory of everything in our lifetime? Or is the universe just too weird to be contained in one equation? I'm off to go find those 7 missing dimensions. I think I left my keys in one of them. See you next time.